Okay, so for question 2, we start the following sequence is a combination of a quadratic number pattern and an arithmetic number pattern. Okay, so there's obviously quadratic and arithmetic here combined. They ask us write out the next two terms. So we just look at that. We see this first term is 1, then negative 37, odd, 3, negative 24, 5, negative 13. So notice which is which. So this is 1, 3, 5. That must be arithmetic. So what would the next one be? You guys did tremendously well, but the next one would be 7. 1, 3, 5, 7. Very good. How this student made it much easier for herself by first writing them separate. Very good. The next one is and this student as well, she got the correct. Next one is 7. Then in order to get the quadratic one, you first had to go and just do this, and this is what she did. She saw this was a plus 13, that was a plus 11. How do we get that? We take term 2 minus term 1, term 3 minus term 2, and that gives us our pattern here. So this is plus 13 plus 11, so the next one must be plus 9 plus 7 plus 5. And so adding the 7 to the 13 gives us, or the 9 to the 13 gives us the 4. And so both of you students, well done for getting that. That isn't a difficult question. But now the next question just throws people off completely. If we consider the quadratic sequence alone, so just consider the quadratic sequence, show that the nth term of this quadratic sequence is, and there it is. And so we have to show this. Now what I want you to notice is that this is not the normal quadratic expression, but and as a result this really throws students off. All you had to do is to find the normal quadratic sequence, which up to there is perfect. Up to that point, that's exactly what it is. And so well done in finding the number pattern there. Let's see, the student did the same and then she stopped. I don't know why. Okay, A is 1, B is 12, and C. So write this. You got 4 marks just for writing it up to that point, and now 2 marks for showing that this answer that you get here and this answer that we have here is the same answer. Now this student, you didn't show that. I don't know what you're doing there. Okay, you seem to multiply in the 1, there's no n there, so it's a little bit confusing. But no, what is the difference between those two? So let me show you the difference. But I mean, you did get most of your marks for that one, so well done. But for example, here I have the general term is negative n squared plus what was it, 16 n minus 52. Was it plus 52 that you got? Okay, minus 52. Okay, so now what can I do with this one to get that other expression? Well, you can do one of two things. You can either simplify this one, minus 8 squared plus 12, and look what you get. So negative n squared minus 16n plus 64 plus 12 gives you negative n squared plus 16n minus 64 plus 12 is minus 52. You see, I could have simplified that, which is probably much easier than taking this one into that format. What is this format? Friends, please recognize this format. It's that x minus p squared plus q format. This is the one format for quadratic expressions. The other format for quadratic expressions is ax squared plus bx plus c. How do we get from this format into that format? With completing the square. To get from this format into that format, we simply simplify. So to complete the square, I would first take out whatever is in front of the n, which is negative 16n. I'll leave the negative 52 outside. Then inside the bracket, I add my half of my middle term, which is 8 squared, which is 64. So I take half of that, square it, and then add it. And then just remember, I've added this now in a bracket, but the bracket has got a negative in. So what I actually did was subtracting 64. So outside the bracket, I must add 64 because otherwise I'm not doing this equation properly. I'm adding things, but I'm not subtracting them, or I'm doing it on one side and not on the other side. So what I do inside the bracket, I must do the opposite outside the bracket. And so this can then factorize into two brackets, n minus 8, n minus 8, so n minus 8 squared, and then this adds up to 12. Okay, that was the other way of doing it. But still, guys, just getting to write down the equation. And the student also, you would have gotten, well, you didn't solve this, you got B, although B is not 12. 3 is 15. Is that where mistake is? See, okay, so you did your working out on paper. You can now see here it wasn't 15, it was plus 13. Plus 13. You maybe went one step back. You maybe do my other method where you go one step back. It does look like it because you get negative 52. Yes, you went back one more step, but then the equations are different. Then the equations aren't 3a plus b, they're just a plus b. And it's not a plus b plus c, it's just c. So in other words, you already had c. C is 52. If you want to do the other method, you must get familiar with the equations. They're much easier, but the equations are, let me see, the equations are 2a is equal to 1, that's good. But this equation is a plus b is equal to 15. Okay, and the other equation then is that c is equal to negative 52. Okay. Next question. Which term in the quadratic sequence will have a maximum value? Now, when we have this expression, that would be my maximum value, because this is basically a parabola. Okay, this is basically a parabola, an upside down parabola, and we know that that is the maximum point then, and that the coordinate of that point is 8, 12. Now 8 is my x value and 12 is my y value, but we're not working with x's and y's. My y value is actually my term value and my x value is my term number. So this means the 8th term is 12, and that's exactly this answer. What is my which will give me my maximum value? Oh, come on, guys. You didn't even attempt it. Which will give my maximum value? Okay, guys, I'm not going to... If you guys don't attempt questions, I can't attempt to correct you. You have to at least attempt it. For now, I will do that. I will explain it, but you guys must at least attempt it. At least one person must attempt it. Okay, write down the maximum value in the quadratic sequence. So which term is the maximum value? Term 8. Because at n equal to 8, that's when I have a turning point. What is the maximum value of the quadratic sequence? 12. And that was 4 free marks. Determine term 52 minus term 8 in the given sequence. So be very careful. The given sequence is that sequence. That's not the quadratic sequence. So term 51, you'll see, is an odd term, and the odd terms are arithmetic. So term 1 is 51. term 1 is 1, term 3 is 3, term 5 is 5. So what is term 51? Term 51 is 51. So term 51 is equal to 51. What is term 8? Term 8 was this maximum term, is it? The 8th term is 12. So term 8 is not 12 in the given sequence. In the given sequence, term 8 is 1, 2, 3, 4, 5, 6, 7, 8. It's the 8th term in this sequence, and we already did that. That was minus 4. You remember you wrote down the terms, the first terms, that is the 8th term. 1, 2, 3, 4, 5, 6, 7, 8 is minus 4. So this term 8 is equal to minus 4. So the difference between that is 55. Term 51 minus 4 is 55. Okay, and still, guys, this is unacceptable. Like, why are you skipping this question? And just because you couldn't have shown this, why would you not be able to show the maximum value of a sequence? Another way to find the maximum value, just to show you, is if you have anything's maximum value, any expression, to find the maximum value, you just take the derivative and make it equal to 0. So what's the derivative of this? Minus 2n plus 16n, so plus 16, that's the derivative, make it equal to 0, so n will solve and you get an answer of 8. Now that's where the maximum value occurs. So what is the maximum value? Term 8 is the maximum. Now to get the maximum, so when I take the derivative, make it equal to 0, I get where the maximum is, or the minimum, whatever. It's the turning point that I'm calculating. The n, or the answer, the first answer I get is where is the turning point at n equal to 8. The next question is, what is the turning point? I substitute that in my original question. So whenever they ask you for a maximum, you can just make that derivative equal to 0 and you work out them. So that's those two. But still, this one, I mean, you could have at least attempted it, because it's just asking you find term 51, find term 8, and simplify. So please, guys, come on. Okay, next question, question 2.2. For which values of P will this series converge? Okay, now this is a series. Notice that there's a term, there's a term, there's a term. And what's the difference between each term? What's the difference between this term and this term? This one has an extra factor. This one has that same factor squared. This one has that same factor cubed. So every factor has an additional term, or every term is an additional factor, and the factor is 1 plus 3p. So let's see, what did the students do here? Okay, multiplying out and going crazy. I didn't even attempt it. Okay, so just to show you, 2 plus 2, 1 minus 3p plus 2 times 1 minus 3p squared. They say it's a series, so it's either arithmetic or it's exponential, geometric, sorry. Which one? Well, this is obviously geometric, because my terms are being multiplied. And what am I multiplying with? What is my constant ratio? Well, take term 2 and divide with term 1. This is my constant ratio. Now they're asking for which values of P will it converge? In other words, when will a sequence converge? The moment, guys, the moment they ask, when will a sequence converge, you start with this. You should actually just start with that. And so now, obviously, we just need to know, what is R? Well, R is always term 2 over term 1. That is why this is a level 2 question. Level 2 is called routine procedure. Okay, routine procedure means it's routine. It's common. And so you take term 2 divided by term 1, get there, and then you know that's R, so we just put 1 minus 3p in there, and then we solve for P, because they ask for which values of P will the sequence converge. So we subtract a 1 everywhere to get rid of the 1, so this is minus 2, smaller than negative 3p, smaller than 0, and then we divide everything with a negative 3p, but remember, in inequalities, the moment we divide with a negative, everything changes around. So in other words, this becomes 0 minus negative 3, smaller than p, smaller than negative 2 minus negative 3. So in other words, p is between 0 and 2 over 3. That's the values for which it will converge. Find the value of, oh man, can it look more difficult than that? Yes, it can look more difficult than that. Can it be easier? No, it can't be easier. It's really very simple. Just take every bit by itself. So let's look at what the students did. And I think this student actually did something like that. The other students stopped with question 2. Yes, this was good. She went and she simplified, took this expression and did nothing with it. Took that expression and just wrote it out and got an answer of 40. Excellent, that's the answer. This expression, 2, what is happening to it? Okay, I don't know where she gets the 44 from. Let me just see, maybe I have the question on. It's from 1 to 2. So what does that look like? This looks like this. This one is, let's get it red. This one is, for P1, it's equal to 2. For P2, it's equal to 2 plus. For P3, it's equal to 2 plus 2. How many times? Dot, 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 up to 2, 32 times. Okay, so 32 times is equal to 64. This is that expression onto infinity. So what are we working with? We're working with the sum to infinity. And so all I need is the first 2 terms, okay? Because all I need is my first term for this one. For that one, I need the sum to, stop doing that, sum, whoop, oh, well, I deleted that now, but anyway, so this one is the sum to infinity, and so for sum to infinity is a over 1 minus r, and that's why I say we need the first term and the constant ratio. So what is the first term? Well, if p is equal to 1, my first term is a half. So a is equal to a half. My constant ratio is r, is my second term divided by my first term. So p is now 2, because p starts at 1 and I must go to 2. P starts now 2, it's 1 over 4. So my second term is a quarter divided by my first term, which was a half. Whoa. Not that, it's a half. and that gives me a quarter divided by half is a half. Okay, and so I just do the sum to infinity. So it's a, which is a half. 1 minus a half is a half. So I get a half over a half, which is just 1. And so in the end, this very complicated expression is a half times, she got the 40, that was correct. A half times 40 times 64, because it was 32, from 1 to 32 twos is 64, and then that just gives you an answer. 40 times 64, it's 128 is 512, 5120 is the answer then. So actually very simple. Okay, but it looks very complex. Okay, I think that's question 2. That's question 2.